Welcome, everyone. It's exciting for us that you have decided to take the first step to get acquainted with CogenS. If you are here, it means that you're either interested in CogenS or have already downloaded our free trial and trying to get started with designing your first CHP Microgrid project with CogenS. At JIS Energy, we believe in empowering people to green up our future and achieve the net zero carbon targets we aspire for. So, we're very eager to give you a jump start in using CogenS through this tutorial presentation, so you can make the most out of your 14 days free trial period. In this video, we will introduce you to the basics of CogenS. We will show you how to set up your project with main input data that gets you started with modeling your CHP microgrid systems. We'll introduce you to the working concept behind CogenS. We'll give you a rundown of how and where to enter system by system input and generate output results. We'll get you acquainted with the final project results section. And finally, we'll conclude with a full walkthrough of a basic CHP microgrid project using CogenS. With that said, let's get started. Before we start diving into CogenS project setup page, it is important to note that CogenS uses 3 different freely available API services provided by the organizations shown on the screen. CogenS comes with default API keys. However, it is important that the user signs up for their own API registration keys and input them in CogenS interface when prompted to do so. To register for an API key, you may visit the web addresses provided in the screen and sign up for your own keys for free. Now let's get started with CogenS project setup. Once you've started CogenS, this is the landing page you'll see. To set up your project, simply fill out these fields starting from top to bottom. It is important that you accurately set up this page, since the rest of the design process will depend on it. When typing the project address, make sure to follow the same format written. Once you've finished, simply click on the next field, then you'll be taken to a new page where you're prompted to enter your API key for MapQuest. You can use the default key written, but it is highly recommended that you use your own key that you're registered with. Once you're done, click OK, and CogenS will take just a few seconds to get the location coordinates, which will be used later in the design process. Another key input for the project is the building weather file. Without it, you can't move on in the design process. To enter it the easiest way, simply use the Fetch button to call for the NREL API service. You'll be prompted to enter the API key. You can also use the default one, but it is highly recommended that you use your own. Click OK, and CogenS will take just a few seconds to get the weather file for your project location. If your call wasn't successful, you can click the Download File button, which will open a web page that contains a database of global weather files. You can download the one for your project location and reformat it into an Excel file. Then simply choose the temperature units for the weather Excel file and the interval of the observations, and click the Import button to input your reformatted Excel weather file. Done. To learn about how to reformat the weather file, click the Help button at the top toolbar and go to the related section for more details. Finally, click OK, and that's it. You can start your design process. CogenS working concept is very easy to follow. CogenS compares the building conventional energy systems with the CHP microgrid energy systems. Once you've set up your project at the project info page, you can start setting up the conventional system modeling tabs, the building energy profiles, cooling, heating, and energy cost. Once completed, you can move on to the Cogeneration system modeling tabs, cooling, heating, energy profiles, and so on until you've reached the Finance tab. Same thing with results. In each tab, you have to enter all the basic input required to model the target system, and make sure you get successful output at the Tables and Plots tabs. Then you can move on to the next System tab. It is important that you don't skip any system and work your way in successfully modeling each System tab until you reach the Results section. As mentioned, each system model depends on the previous one. Now let's see how that works on the system level. When you click OK at the Project Info page, the default view is the Energy Profiles tab. You simply enter the input data required for the electricity, gas, oil, cooling, heating, and domestic hot water energy profiles, with the same time interval you specified at the Project Info page. Starting from the left panel, enter all input for the enabled fields from top to bottom. Then, move on to the right panel following the same rules. Click the Calculate button when you see one so that you prompt CogenS to run the functions necessary to generate the output for the system. In the Energy Profiles tab, the Calculate button will generate the peak, minimum, and average loads, plus the load factor for all the energy profiles entered. Once done, click the Tables tab. Simply click the Calculate button to generate the monthly and annual energy consumption for the building. This will be used later for comparison purposes with the CHP Microgrid system. You can change the units for any energy profile you want by double-clicking the Units drop-down menu as shown, then selecting your desired units for the row. The row values will automatically be converted when you do so. Once done investigating your energy consumptions, you can move to the Plots tab. At the Plots tab, you can plot the energy profiles in the interval you selected at the Project Info page. If you selected a time interval that is less than 60 minutes, you can go to Hourly Energy Profiles to view your energy profiles in 60 minutes intervals. It is important to note that these are energy, not power profiles. To start plotting, you can simply click the profile you'd like to plot at the Legend panel. To control your plot view, hover around the plot area until the Control toolbar appears at the top right of the plot area. You can also change the plot units by selecting from the drop-down menu at the top left. You can also explore other plot types on the system level by navigating to the appropriate tab. Once you've worked your way through every system input and output following the design process and have reached the Results section, you'll need to start with the Summary tab. Click the Calculate button and a number of pie charts will be displayed. You can immediately tell if a CHP microgrid is feasible for your project. You can find a detailed description of each pie chart in the user manual. Next, you can move on to either Tables or Plots. Both Tables and Plots, for the Results section, have the same user interface controls. Select the interval you'd like to view your data in from the drop-down menu, then click the target variable you'd like to see in a tabular or graphical format from the buttons listed on the right and left of the View panel. You can find detailed description of each variable in the user manual. Now, let's watch a video of a basic CHP microgrid project design from beginning to end. First, let's save our project and give it a unique name. Now let's fill out the project info. We'll choose a commercial building type and a basic CHP project that might be coupled with a solar array, metric units. Then, get the weather data. Great! Let's get the energy profiles. We'll choose Method 3 and get typical electricity and heating profiles for the building type I'm designing for. We'll choose a small hotel and call the NREL API. The profile orientation automatically changes when we call the API, and we should keep it as is. We'll leave the peak loads the same as the typical profile loads. Click Calculate to get the initial project indicators. Then, I'll get the grid emissions factor using the NREL API. Great, I'm done here. Here's my monthly and annual consumption. And now I can check the plots I want to investigate. Moving on to heating. Let's assume it's an oil boiler. I need to know my peak heating demand. This is the input energy demand for the boiler. So going back to heating, I'll choose a unit sized at 25% more input than the peak. That's approximately 175 kilowatts. I'll assume this is an 80% efficient boiler. Look, my rated output has already changed. I'll leave everything else as is. Click Calculate, and there it is. Since we don't have a domestic hot water profile in this project, we don't need to do anything with the input for it, and we get 0 results here in the Tables tab. Awesome! Let's enter our energy costs. For a simple project, we'll just use a blended rate. Just click the NREL API. Let's assume $2.5 per gallon for heating oil price. Because I didn't input a gas profile, and my equipment for the conventional system don't consume natural gas, I can leave the gas energy charges as is. We'll go to Tables, Calculate, and by reading these 2 quick reminders, I think we're good to go. Great! Everything looks good. This tells me that the total annual cost of energy for a conventional energy system is around $87,000 a year. Now is a good time to save my project. Let's jump into cogeneration. Since I don't have a domestic hot water system, and I still need to size my CHP system, I will skip this input section for now, then I'll come back to it later. But I still have to calculate the tables for this section to move on to energy profiles. We'll go to Energy Profiles and calculate our new heating and electricity loads that will be used to size and model the CHP microgrid. I'll check my tables. Looks good. I can just copy the same electricity and gas rates I entered in the conventional section, but I must enter the gas energy rates, 60 cents per therm. I'll choose a net metering billing type. That's it for energy cost. The tables for energy cost are calculated when we run the energy resources model. Let's size our microgrid. Click Calculate. It is telling me to add the solar array system input, but I'll skip that for now to see the sizing with just a CHP system. Looks like I have a good electricity baseload throughout the year, but my heating baseload is much lower and not as consistent. If I run the CHP continuously at full load, I'll be wasting too much thermal energy. Seems like a good solution here is to size the CHP system at 20 to 30 kilowatt thermal output. That means I could use solar PV as part of my microgrid to make up for the lower CHP capacity. Looks like a 100 kW AC system might be a good choice. And my auxiliary boiler output should be greater than a 100 kilowatt. Great! Maybe this is a good time to save my project again. Let's go back to heating. I'll size my auxiliary boiler and maybe choose an electric one. It should be very efficient. Let's also do a variable water flow type. Looks good. Let's jump to energy resources. Almost there. How about we keep the rice CHP and size it at 15 kilowatts electric output, but choose 2 units instead of 1. We'll keep it fixed output control for such small units, but we will sequence them so that they meet but not exceed load. We don't want to waste any thermal energy. Great. Now let's use a 125 kilowatt nameplate for solar. We'll keep everything as is and call for the NREL API. Good. Very close AC output to what I'm looking for. We'll change the price point for the solar to a lower bracket. 1,800 per kilowatt seems fair. Now I'm ready to calculate my model. Seems like I don't have any waste heat in my CHP, and my CHP is producing almost half my heating load. But the boiler is running almost all year, which adds a good amount of electric energy. I can go back to see my boiler tables and plots. I can also check how my CHP units are sequenced based on runtime. Let's see the Finance tab. Let's do a financial model from the building owner standpoint. We can just calculate the depreciation cost and keep everything else as is. Calculate the model, and there you go. Let's see the bottom of the model. Our internal rate of return is almost 10%, not bad. Let's conclude with the results section. Click Calculate, and there you go. Annual financial and emission savings. Wow, looks like a winner project. We hope you've enjoyed this video, and please don't hesitate to reach out to us with any questions.